So, taking advantage that we have people in the room as well, I'll first go to the floor in the room if there are any questions. We have a few questions online already. So, any burning questions from our different panelists, speakers? Yes, in the back. Matt.
Industry Act that the heat pumps were included as a technology. Is there any developments on the expander technology also being included in the Net Zero Industry Act? I don't know who that's to, but
you will have microphones there if you want to try.
Probably is on. Okay, sorry. If you can repeat your question because we can hear very well from here.
Sure, no problem. You mentioned earlier, I think Marco mentioned that heat pumps were included in the Net Zero Industry Act. Indeed. Just wondering if there's any developments on the expander technology also being included in the Act.
We are indeed working on it. We know for sure that, for example, in the taxonomy regulation, we are a lot of room for improvement for this kind of technology. But even if for heat pumps, we are know that are included in strategic net zero industry technology. There is no the same mention for the gas expander. We know that we are a lot of room for improvement, and we are working on it. We hope for next couple of months or 6 months, actually, I would say, there will be more clarity on that point. But I agree with you. It's a very important point.
Thank you. I'll turn to some questions now that we received online, and I think it's directed more towards the heat pump experts. So the first question, well, two questions really related to heat pumps. It says, since waste heat is sometimes intermittent and fluctuating in terms of temperature or flow rate, can heat pumps operate in this kind of scenario to provide constant targeted output, heat flow, and temperature? And then I guess the follow-up question really is, will this have an impact on the lifetime of the heat pump if it were to fluctuate?
Yes, good question, actually. I forgot to mention that basically it happens that within the scheme of how the steel production works, let's say the steam for the booster is not available all time, so the heat pump has to, let's say, vary its output directly producing 120 degrees C. Whereas concerning the cooling circuit of the furnace is always kept in operation, also during, let's say, the stop of the furnace due to thermal inertia, which means that from heat pump perspective, we always have the heat source available. So we just modulate in terms of output to reach the 120 degrees C to bypass the steam booster. So the heat pump modulates to, let's say, follow the variation from both sides, because steel mill, I mean, the values reported were, let's say, the design temperature, but of course, in industrial processes, there are always variation also due to the season. And at the same time, there are variation in terms of district heating network for season. So the system can adapt, self-adapt fully automatically to those variations.
Thank you. Looking to the audience again, if there's anyone in the room that has a question. Hans? The other Hans?
Actually, it's a question to Alessio. I saw in his presentation that he uses the average CO2 of electricity in Italy. And I wonder, isn't it more correct to use marginal CO2 levels linked to electricity in this project?
So Alessio, if you're online, you heard that? Yes, you've unmuted.
Yes, I can hear. Maybe, but I remember that the KPIs definition was validated in accordance to the project monitor, and so for this particular case in Italy, we are according to use this value. But okay, I give the input from the from your side, and we can consider this task, of course.
Okay, turning to some online questions, and this is directed to RINA, so our two speakers online. So first of all, thank you for the presentations. What are the PBP of the three cases for simultaneous heat and cooling? How does the higher induced lift, almost 100,000 here, influence the COP and the competitiveness of the project, bankability? So either Alessio or who else? Fabio online.
The payback period depends obviously from case to case, and it is between 2 and 6 years from case to case. And for the technical point of view about the induced lift and the COP, and also for the working fluid, I don't know the answer of this technical question. I don't know if TURBODEN maybe know how the heating and cooling can influence the technology of the large heat pump.
I think, yeah, TURBODEN would like to answer.
If I can add, I mean, we agree with the, let's say, with the order of magnitude in terms of payback time. Of course, it always depends on the boundary condition of the project, because we always have to consider, let's say, where the project is placed. For instance, we are constructing a larger heat pump in the Nordic region, where the let's say there are good boundary conditions for project development, even with a COP in the range of 2, which is quite low, of course, talking about an heat pump, but in that case, energy mix has a very low carbon intensity, because the energy mix of Finland is based on hydro and nuclear, so it allows to reduce also the CO2, let's say, emission related. The natural gas price is high, but in terms of payback, of course, in industrial feed, we are what we are seeing from our analysis, we are between 2 and 4 or 5 years. Then it depends if you are doing also cooling, let's say combined heat and cooling, let's say the payback, let's say decreases, because you are also saving a huge amount of electricity for the cooling, because you have a twofold effect of the heat pump that can both heat and, let's say, cool the network.
Thank you. And another question to RINA, and I believe this is probably directed to Fabio, about the heating and cooling project in the dairy plant. Does the higher lift require a change in the working fluid? Technical question, but maybe Fabio, you can answer that.
Yeah, the second question about the working fluid from Charles.
Yeah, maybe Fabio, I can let's say make a comment on this. What we as TURBODEN do as, let's say, heat pump manufacturer, we do plants, and we have a quite wide range of fluid that we can select from our library, so we can select the proper fluid for the, let's say, proper temperature. We have fluid as a refrigerant, but also natural refrigerant such as hydrocarbon, which is, let's say, the expertise of our company, capable to evaporate below 0 degrees C, which means that we can start to recover or produce cold below 0. So from a dairy chain, for instance, which could work with 7.2 or 12.7 degrees C, we can select fluids such as butane or modern HFOs. So we can say that we have the proper fluid to do that, whereas for higher temperature, for instance, maybe the example showed in refineries, we use fluid more, let's say, suitable for higher temperature, because we optimize the compression of the working fluid, selecting it.
Thank you. Looking to the audience again, no questions. I have one more final question here from online, and this is a question related to the heat temperature in data centers. Do we have an idea what that is, and can it be harnessed for ORC or a large heat pump?
Okay, so we in our report identified the sectors where large heat pump can be employed, and from the reference we used for the report, data center was identified as potential for the for usage of heat pump at we mean for temperature below 100 degrees. In this case, I don't know the exact temperature, and so.
Okay, and I guess if it's below 100 degrees Celsius, can it still be used with an ORC in a large heat pump?
Yeah, and of course, just adding that for this kind of technology, there is very huge potential that obviously with different case, different temperature indeed, and different possible scenarios. So it's a very interesting question, but probably we can answer more in deep where later on with after sending, I don't know, sending additional information or sharing our presentation, but it's one of the point in, of course.
Okay, a few more questions online here. So thank you for the active participation of everyone online. If one requires hot water at 90 degrees Celsius, what kind of impact does this have on the efficiencies of the heat pump as opposed to 70 degrees Celsius? Does the COP change?
You mean to reduce the temperature?
Well, instead of having 70 degrees
as heat source.
As
okay,
a heat source,
yeah.
yeah.
Of course, it affects the COP because higher is the lift, the lower the COP. So most probably with the same configuration, the COP could decrease. I would expect 10-15% less, but I would say that's 50 degrees C. It's still a valuable heat source to higher in temperature, and we are seeing from those kind of waste stream that they are valuable also to produce steam as output, not only superheated water, but as shown in the let's say the case studies RINA shared. Medium temperature such as 50 degrees C with the proper fluid can also allow to produce with a good COP in an order of 3, still 2-3 bar steam, which are suitable for several processes, I would say, as also Zina underlined in its research.
Okay, thank you. Another question online is about energy performance contracts. Is there a framework or standard with respect to such contracts in the EU? And are there relevant regulations? Unfortunately.
Yeah, on this point, there is no framework or relevant standard in EU about EPC, and indeed the main type of energy performance contracts I present are the most common, but also each one of them are not regulated and can be quite different from case to case.
Okay, thank you. And let me just take a look here. Any more questions online? I don't believe so. And if there are no questions in the room, then we can close the Q&A segment. So thank you again to all the speakers in person and online.